Welcome to UMath. Our special guest today is Todd Flanders. Todd Flanders is part of the Flanders family, the next door neighbors to the Simpsons. Todd is a little bit on the naive side, but he is a very kind Christian boy. See you, Todd. Today we're going to be talking about the Pythagorean Formula, which was named after a very famous Greek mathematician and inventor named Pythagoras. We talked a little bit about this guy. One of his inventions was this cup, and we talked about this Pythagoras cup, where he was asked by some vineyard owners to come up with a cup that could keep track of whether some of the workers were pouring too much wine during their breaks. But the thing he is most famous for is his formula. And his formula is related to right triangles. Now, why is he famous for this formula? Because it has proven to become very, very useful in a number of different occupations, such as for carpenters and architects, and has been used for centuries and centuries after he came up with it. And it's widely used today. So, if you have a right triangle, let's go over the terminology first. In a right triangle, the longest side, which is directly across from the 90-degree angle, is called the hypotenuse. The other two sides are called legs. And each of these sides is also represented by a letter. So one of the legs will be called A, the second leg is B, and the hypotenuse is C. Now, if you mix these two up, it wouldn't be a big deal. If you called this B and this one A, it wouldn't be that big a deal. But the hypotenuse always has to be C. Otherwise, your formula is going to be messed up. So what is the formula? The formula says this. If you are given the lengths of two of the sides of this right triangle, you can use the formula to figure out the length of the third side. Works every time. So here's the formula. C squared equals A squared plus B squared. So let's actually do a question here. Let's say that this leg is 3 centimeters and this one is 4 centimeters. And now we're going to try to figure out the length of this side using the formula. Now, because we're trying to figure out C, we put nothing for C. We just leave it as is. And of course, you start by writing the formula. You do that for any question involving a formula. Now, A, we said, is 3, so we put a 3 where the A is, and it's squared. Plus, for B, we said it's 4, so we put a 4 where the B is, and it's squared. BEDMAS says we have to do the exponents first before the addition. So 3 squared, we know 3 times 3 is 9, plus 4 squared, 4 times 4 is 16. And then finally we add them, and we get 25 as a sum. Now at this point, remember the rule about doing variable equations, that if you want to solve for the variable, you ask the question, what is being done to the variable, and you do the opposite. So what is being done to the variable C here? It's being squared. So what would be the opposite of squaring something? It would be finding the square root. There's the radical sign. We do them on both sides to keep everything equal. Now, by finding the square root of a square, in essence what we've done is we've just crossed it off, canceled it, and now the variable is alone. We say, what's the square root of 25? Well, it's 5. We have to include units because we're trying to figure out what the length of this side was, and it's in centimeters. So the length is 5 centimeters, which makes sense. Whenever you do these questions, you could just look at the other sides, the legs here, and say, well, if this one's 3 and this one's 4, we can actually see that this side here, the hypotenuse, is a little bit bigger than this leg here, so a little bit bigger than 4, and 5 totally makes sense. So let's just do one more here. Let's pretend this one worked out really nicely without any decimals or anything. So let's do one that doesn't work out so cleanly. Let's pretend this side is 6 and this one is 7 centimeters. So start with the formula. C squared equals A squared plus B squared. A is 6 squared. B is 7 squared. 6 squared is 6 times 6, 36. 7 squared is 49. Remember, we do the exponents first before the adding, according to BEDMAS. And then C squared equals 36 plus 49, which is 85. And we've got to get the C alone, so we do the square root. There's the radical sign. Have to do it on both sides. And those cancel. C is now alone. And the square root of 85, well, this one's not as easy as this one was here, where we could just figure it out easily in our head. We know this is going to be a decimal. The square root of 81 we know is 9, and the square root of 100 is 10, so it's got to be 9 point something. We know that. So at this point, if you get a question like this where it doesn't work out so nicely, you can just punch in 85 on your calculator and hit the radical sign, and you come up with, well, when it's rounded, it's going to come up to 9.2. And of course, we have to include our units on that. There's also a chart in your book, if you remember, for finding out square roots. So you could use the square root chart in your book as well. There's actually 2 of the charts in the book. So once again, we look and we say, well, if this side's 6 and this side's 7, then it totally makes sense that this side is about 9, because it's a little bit bigger than the 7. So that is Pythagoras' formula.
That was easy.